Okay.
Allison's fine.
So we're going to talk about radians and central angles today. It's a pretty easy lesson, especially since you've worked with radians before in physics.
Is it 2 pages long?
Yes.
It's gonna be okay.
All right, another way to measure an angle is with a radian. See if I can spell radians right. Maybe. All right, in the late 1800s, mathematicians began to need to see a method for another unit of measure for an angle because they needed the measurements to cancel out. So radians have no units, right? It is just a radian. It is a measure of the angle. There are no units. One complete circular revolution is 2 pi radians, which we saw on that little exploration that we did yesterday was about like 6.28-ish.
6.28-ish.
And then we also saw that 1 radian was approximately 57.296. So a lot of y'all got like 60 degrees or like 59 or 58, which is all really close to 57. So I mean there's some error because we were using
68.
68. That's kind of a lot of error, but your string was probably just too long. So it's okay, but
it was a little off.
A little off. The important thing to note is that a radian is the angle measure when the radiuses and the arc length are all the same size. Almost like an equilateral triangle, but it's like a sector, not a triangle. All right, but all of the sides are the same. And that angle that's being formed makes 1 radian. All right, the definition of a radian is based on the concept of a unit circle, and a unit circle has a radius of 1, with the center being at the origin. So remember I told you that our center is always going to be at the origin at 0, 0. The radius won't always be 1, but once we start talking about the unit circle, that's a special circle with a radius of 1. All right, so we're going to get to that next unit, not this unit. But we do a lot with the unit circle.
Isn't that the one we have to memorize?
Yes, the unit circle is the one you have to memorize.
Oh, yeah.
And then 1 radian measure is the measure of the central angle that intercepts the arc that is an equal length to the radius. So that's kind of just the picture I drew where all of the lengths are the same and that makes 1 radian. Okay, so the circumference of a circle is 2 pi r. And that 2 pi is kind of coming from the radians. So it's 2 pi and then times whatever your radius is. That will give you the circumference. And then we have arc length, which we're going to start working with a lot tomorrow. And arc length is going to be the radius times your angle measure, but your angle has to be measured in radians if you're using this formula. So back in geometry, you probably did arc length with a different formula because you did it with degrees. So that's why you might be like, that formula doesn't seem familiar, because that is a formula for radians, not degrees. Okie dokie, so let's talk about some common radian measures, and I'm actually going to start with example 11. I don't want to do 10 first, so I'm going to make a note for myself for next year.
Is 10 difficult or something?
It's just a negative, and I'd rather do a negative after we do the positive ones. Flip examples. Okay, so just like we did with degrees, so you remember with degrees when we were kind of measuring something, we would write 0 degrees, and then this was 90. Don't write this. This is 180, and this is 270. I know, I saw you figure pencil. So with the degrees, we labeled like our 4 corners. We're going to do the same thing with radians. Okay, so this is a radian question, so I'm going to do the same thing with radians. This is going to be 0 radians, which is the same thing as 2 pi, because a full circle has 2 pi. All right, so what would half of my circle have? 1 pi. The whole thing has 2. So if the whole circle has 2, then if I just went halfway, it would have pi, or 1 pi.
So pi over 2 is...
Yep. So then at the 90-degree mark, so a quarter of the circle would have pi over 2. So each one of these little like 90-degree measures is the same thing as pi over 2. So it goes pi over 2 plus pi over 2, which makes 1, right? 2 halves make a whole. Then plus pi over 2 is going to be 1.5, which we're going to write 3 pi over 2. So that's just the, what's called, improper fraction of 1.5. Right, you know what I mean?
Mm-hmm.
1.5 is a fraction, is 3 divided by 2.
Yeah.
Mm. That makes sense.
And then if you add another half, you pop up to 2 pi. And you could keep going around and around and around, just like we do with angles, degrees. So if I want to draw where pi over 2 is, that is this guy right here in between the first and the second quadrant. Okay, so on example 12, once again my four corners are 0, pi over 2, pi, and 3 pi over 2. And y'all get better at like memorizing those. Knowing the four corners is important. It helps. So if you were wanting to draw where pi is right here in between the second and the third quadrant. All right, so now we're going to pop back over here to example 10, which is the hardest one. So first thing I'm noticing is that it's negative. So when I do my little corners, I need to go backwards. So this guy here is going to be 0, and if I go backwards, this guy is going to be negative pi over 2. So going backwards. And this guy there is going to be negative pi, and then up top would be negative 3 pi over 2. So where would you draw negative pi over 4?
It's in between 0 and 2. And
Yeah.
5,
So right here in quadrant 4, between 0 and negative pi over 2. So this would be where negative pi over 4 goes. Okay, so that's kind of drawing them. You're going to have a couple of those questions. I think the first like 8 on your homework is either drawing or stating what quadrant they're in. Now let's talk about converting, because that might help you if you get stuck with the drawing. So we are going to be converting from degrees to radians and radians to degrees. And so we have these two conversion formulas. So if you are going from degrees to radians, you would multiply by pi over 180. If you are going from radians to degrees, you are going to multiply by 180 over pi. So they're very similar formulas, which makes them easy and sometimes hard to memorize because you'll get them confused. So this is the way in my head that I have it memorized. Radians will normally have pi in it. They don't have to, but normally you will see radians like pi over 2 or 3 pi over 2 or 7 pi over 4 or something like that. So normally radians will have pi. So if I want pi, then I want pi on top, right? Because I want it to stay in my number, and it's normally on top, 7 pi over 4. So if you're trying to change to radians, you want pi, we're going to keep the pi on top. So if you're changing to radians, you would multiply by pi over 180. Where if you change to degrees, we normally do not have pi. Doesn't mean you can't, it's just normally not seen written with a pi. And so if you want to get rid of your pi's, you are going to multiply the guy with pi on the bottom so the pi's will cancel. So that's kind of how it's worked out in my head, but regardless, you do need to know which one to multiply by if you want to change the forms. Y'all did that in physics though, right?
No.
No, you didn't
We
go from
never-
degrees to
we
radians,
haven't
radians to degrees?
We might have, but I don't know.
Okay. Well,
No,
I don't pay
commercial.
attention.
anyways.
Even if we did,
We just have stuff in your head.
we just be doing stuff.
All right, on these next 6 examples here, we're going from radians to degrees or from degrees to radians depending on what I have. So the way you know if you have a degrees or a radians is if you have that little circle. So you see all of these on the right side, you see how they have the little degree symbol? That's a degree. You see how all of these don't have the degree symbol? That's a radian. So if you had an angle, maybe, if you had an angle that said 300, is that a radian or a degree?
Degree.
Radian,
Degree size.
because there's no degree symbol. If you had something that said 2 pi and then that with the degree symbol, it's a degree. Now, rarely do you see a radian that large or a degree symbol with pi. It's possible though. All right, normally we will see our degrees actually multiplied out, so that would probably be written more like 6.24 or something degrees as opposed to 2 pi. I just want you to be aware that that's possible. What makes a degree is the degree symbol. What makes a radian is no symbols, because there's no units for radians. But I would say 99% of the time, your radians will look something like this with pi in it. Your degrees will look something like that, kind of a larger number with the little circle. Okay. So I'm wanting to convert this to degrees, so I'm going to multiply by 180 over pi. I'm going to degrees, so I know I want to get rid of the pi's, so the pi should go on bottom. That's how I have it logicked out in my head. Now, remember, this whole test is calculator. You can plug this in, but there are some kind of simplifying strategies that will help you with time. So first of all, what happens with your pi's? They cancel. So you don't have to worry about plugging pi's in. That's going to save you some time. And some of you, which are good with simplifying fractions, you might even be able to do this in your head. What is 18 divided by 6? 3. So that's going to just turn into 30 because the 0 is going to hang out still. And then what's 7 times 30?
Who knows?
What's 7 times 3? Yes. Because 7 times 3 is 21. That 0 is still hanging out. And then make sure you put your degree symbol to...
Otherwise it's going to be counted wrong.
Yes, otherwise I'll count it wrong.
Partial credit.
You get partial credit, but I would count off for not having the degree
1
symbol.
point.
All right, so this one here, we are going to multiply by 180 divided by pi. So the pi's are going to cancel. Same thing, this one's not too bad to simplify, because what's 18 divided by 3? 6. So that turns into 60. So 2 times 6, or negative 2 times 6.
Is it a 120?
Negative 12, and then the 0 is still hanging out.
Oh, it's
So,
negative 120?
yep, negative 120. So if it's negative and you convert it to degrees, it'll still be negative.
Yeah, but I didn't know if there was a negative symbol and you're supposed to use it for the top and the bottom.
Gotcha. No, it just goes to the top.
Oh, okay. Hi, Jude.
Okay, and then the last one, the last one here. This one's a little bit harder to do. It's a little bit weirder to simplify, but that's why, once again, you could just type this in your calculator. Negative 8 times 180 divided by 15, which I think is going to give you negative 96 degrees. All right, so radians to degrees. We good with that? Okay, so now let's talk about degrees to radians. So this gives a degree because it has the little open circle, and we want to convert it to radians. So I'm going to multiply it by pi over 180. And when you write your radians, I want you to get used to writing it in terms of pi, which means don't plug pi into your calculator. So in your calculator, I'm going to do 135 and times it by 1 over 180. Whoa.
So 3/4.
So you get 3/4. Or you also could do 135 divided by 180 and then math, enter. Either way, but get the fraction. Don't plug pi in.
And it's 3 pi over 4?
Yes, because that's normally how you see radians is written in terms of pi. So your answer would be 3 pi over 4. You also could write it as 3/4 and then pi off to the side. You normally don't see it written that way. You'll normally see it the way I boxed it, but they are both the same thing. But for some reason, they put the pi's on top. All right, so this guy here, same thing. We're going to multiply by pi over 180. And so you can type that in your calculator, get your fraction, which I think is negative 16/9. And then we're going to just include the pi up top. And keep it in terms of pi. So that's what it means when if something says leave your answer in terms of pi, it just means don't type pi in. In the end, it will just have pi in it. Does that make sense? All right, and so then the last one here, we're going to multiply by pi over 180. Nothing different. Negative 11 pi over 18. That one's not too bad to simplify because the zeros just cancel. Okay, so that is changing from degrees to radians and radians to degrees. So now let's talk about these word problem questions. All right, so 19 says how many radians are in each angle if are of an equilateral triangle. So since we are more familiar with degrees, you could work this whole problem out in terms of degrees, and then at the end, change it to radians. So in a triangle, how many degrees do I have in a full triangle? 180. So your total is 180 degrees. Now, if it is equilateral,
60, 60, 60.
Yeah, each angle is 60, 60, 60. And then we're just going to take 60 degrees and we're going to multiply it by pi over 180 to get pi over 3. So, in radians, each angle is pi over 3. Does that make sense?
Yes, ma'am.
So, on 20, it says the minute hand of a clock travels how many radians in 15 minutes? So, your minute hand, you go like 0 and I don't
really know.
So this be negative?
We just want to know the degrees because it's going clockwise, you mean? I'd be okay with either answer.
Wait, what?
He's asking if you're going to put your answer as a negative number because you're going clockwise, because it's a clock,
Wow.
right?
Yeah.
Or if you're just talking about the angle itself. So I'd be okay either way. But we do need to figure out how much are we traveling in 15 minutes. So 15 minutes is going to make a 90-degree angle with your clock, right? You go 0, and then in 15 minutes you would hit this horizontal line. 30 minutes would be halfway, 45, and then 60 because the whole clock has 60 minutes in it because it's an hour, right? Does that make sense? Okay. So from 0 to 15, how many degrees are we traveling in 15 minutes? 90 degrees.
Oh.
And then you can convert that to radians, which would be pi over 2. And I'm okay with negative pi over 2 as well because you are going clockwise. Another thing, if you just start knowing your radians, that you know that a quarter of your circle is pi over 2 in radians. So like if you knew your radians, you could just go straight to saying pi over 2. Does that make sense?
Mm-hmm.
But if you don't know your radians, get your degree and then turn it into radians. Okay, so similar question, but now my minute hand of the clock is traveling only 10 minutes. All right, so we are I'm going to split 15 up. All right, I'm going to split it up to be 5 and 10. So if I'm going 10 minutes, well, if I split this up, how many is each little angle here? 30. Because each each little angle here is 30 degrees, 30 degrees, 30 degrees. Because the whole thing makes 90, right? So if I'm going to 10 minutes, what's my angle? 60 degrees. And then if you convert that to radians, times it by pi over 180, which is going to be pi over 3. Okay, and then last clock question. Now we're talking about my guy only going 5 minutes. So same picture, 5, 10. If we are only going 5 minutes, what's my degree? 30. And so when I turn it into radians, 5 or 6. All right, last 2 questions. So it says, what is the measure of theta in radians if x is 45 degrees? So this guy right here is 45 degrees. And I want to know what this whole angle is from 0 to the end of your terminal side. So what am I going to subtract from 45? I mean, yes. 360 minus 45. Which is going to give you 315 degrees. So I know that this terminal side is at 350 degrees, and if I want to turn that into radians, I'm going to multiply by pi over 180 to get 7 pi over 4.
Do you like this unit better than last unit?
Oh, I like every unit better than last unit.
Oh.
Last unit's my least favorite.
What about the one you forgot about, unit 7?
What?
Remember when she forgot about, like, you forgot that to put unit 7 in your...
That was in calculus.
Oh.
I forgot a whole
I'm
unit in
sorry.
calculus.
I thought you were...
I was like looking at him, I'm like, where is the first root that I completely left out an entire unit? So we had to squeeze a unit in right before the end of the semester. It was rough. That was on me. Luckily, we're working out a lot of kinks in calculus, so next year it's gonna work out better. Kind of like we're working out kinks in pre-cal, but it'll be fine.
Yeah.
Okay. It really hasn't been that bad. On this one, what is the measure of theta in radians? So what do I know about this whole angle right here?
180.
It's 180. So I know that 180 is going to equal x plus 5x. All right, so x plus 5x is 6x, which means that x is going to be 30. Now, that's not the answer. That tells me that this is 30 right here, and I want to figure out this bigger angle right here. So what are you going to multiply 30 by? By 5. Or you could subtract it from 180.
Oh, yeah.
180 minus 30, is that what y'all did instead?
Yeah. So now you have to find it in radians.
Oh yeah, and then we have to find it in radians. Did I do radians on the last one? I did. Okay. So 150 times pi over 180, which is going to be 5 pi over 6. Okay, let's pull your homework out because there was, I think, one question I wanted to talk about, maybe.
I was using my dad's card to fill in my house and I put it free. Alexis only takes 3. That's what my grandma says.
She does not look
Okay,
I don't put free.
on problems 1 through 4, you're just drawing the angle. We're not going to do reference angles with radians, so you just are drawing what quadrant it is in. And then on 5 and 8, you are going to state the quadrant that it's in. So if you have to sketch it out, sketch it out. All right, you get a little bit more complicated with your fractions here. All right, we didn't talk about finding a positive and a negative coterminal angle, so let's talk about number 9. All right, so if I want to find a positive and a negative coterminal angle, what do I need to add and subtract to pi over 3? Say it again. 2 pi. Now, I can do this in the calculator. I'm just not going to type pi in, right? Because they both have pi. It's almost like your like term. So I'm gonna do 1/3, and I'm gonna add, bless you, add 2. And so one of my coterminal angles is gonna be 7 pi over 3. And then I'm gonna do the same thing and subtract, bless you, subtract 2. So the other one would be negative pi over 3. All right, so you would get 7 pi over 3 and negative 5 pi over 3. All right, when you write your answer, make sure you put the pi back in. Don't write it as just the fraction. And so that kind of idea might be helpful, especially on some of these like bigger fractions. And then you've got convert from radians to degrees, and then degrees to radians, and then some problems like we just did. All right, y'all feeling okay on it?
Yes.
All right, you got a homework quiz tomorrow.